The Feudal Future Podcast.
Hello and welcome to another episode of the Feudal Future Podcast. I'm Marshall Toplansky.
I'm Joel Kotkin.
And today we are going to be tackling a really interesting topic, semiconductors. We've heard a lot about the CHIPS Act. We've heard a lot about the economic development of the United States and the shift back to the U.S. for chip development. We have two really great speakers here today. Dr. John Berry, who is the president of Central Ohio Technical College. John, welcome.
Greetings. Thank you all.
And Ashwin Rangan, who is formerly senior vice president of re-engineering and technology at Connexent and an old friend of the show. Ashwin, welcome back.
Thank you.
Joel, you want to kick us off?
Yeah, sure. The CHIPS Act is obviously being seen as a major strategic attempt by the United States to recover an industry which was born here, particularly here in the state of California, and has moved elsewhere. What are the biggest barriers to this idea of reshoring the semiconductor industry in the U.S.?
I think that's a wonderful question. When you think of semiconductors, everybody's chasing what is known as the bleeding edge of semiconductor, which is the lowest level of nanometer technology that can possibly be effectively produced at scale. And that takes multiple input factors. So purely from an economics perspective, it takes the typical input factors of you need the right people, you need money, and you need the equipment. When the act was passed, none of those three were in a state of preparedness to take complete advantage of the act. And the act was passed in 2022. Here we are right in the middle of 2024. The money is only just starting to flow toward people who are interested in making their own contribution outside of the subsidies that they receive. So now there is talk about, all right, assuming that the shell for a wafer fab is available. That's a big assumption because that says that people know how to build one. Where is the equipment going to come from? How fast can the equipment be made? And how soon will it arrive here? Just to give you a sense, a piece of ASML equipment that is responsible for deep UV lithography, as it's called, costs about $350 million, give or take, and is the equivalent of about 10 trailer trucks, one piece of equipment for one step of manufacturing. So we're talking about very complicated stuff here.
Well, and one of the things that actually was the trigger for this show was a comment that I heard you make recently, Ashwin, that when the Intels of the world and the TSMCs of the world, Taiwan Semiconductor of the world, were considering the notion of building plants in the U.S., they went looking for talent to be able to actually do the construction work and then ultimately do the operational work, and they couldn't find the people. So that kind of brings us to the question on your side, John. It's that what is the need out there as you're seeing it in Central Ohio, and extrapolate that out to the U.S.?
Yeah, Marshall, appreciate that. And what I would tell you is we are finding ourselves in an unusual set of circumstance within this design. Semiconductor manufacturing is something that's brand new to the state of Ohio. This is not something of which we had a rich history, a strong foundation within. But what we do have is a significant foundation of advanced manufacturing. That has been a strong point of Ohio, Central Ohio especially. It's still been a very healthy element. If you think about the state of Ohio and the whole notion of Rust Belt, with so much of the industry having moved out, this has always been a core, and it has maintained a strong level of significance. Companies like Boeing, those sorts of elements that we've been doing, production engineers to support that network. Now, extrapolate that into what we're talking about with semiconductors. We had to be able to first understand the industry. What is it that this production requires? And Ashwin hit it on the head. This takes a lot of initial support to generate and to design. And for us, our charge was to produce the workforce element both the engineers who are operating the functional systems within the fabrication centers, and then the construction of the sheer size and scope of this fabrication design. We were talking a little bit ahead of time about the sheer size of this construction project. It is the singular largest construction project in the history of the state of Ohio. So just providing enough workforce of skilled tradespeople, those who are in construction, those who are doing plumbing, electric work, that has been sort of a heavy lift, but it's going fairly well. The foundation for this fabrication center, the first two designs are well underway. They finished their basement, which was truly the foundation of that process. And now we are really trying to ramp up the production of the people to work the fabrication center.
So what kind of skills do you have to teach in order to be able to effectively meet the demand here?
Yeah, that's a great question. And the interesting part for us is we talked about advanced manufacturing and how that has been a common core. But sometimes, candidly, gentlemen, manufacturing is not seen as very sexy. This is so oftentimes people have the notion of the 3Ds, that it's dull, it's dirty, or it's dangerous. That's the antithesis of what Intel kind of brings to the map in this world. At its core, this is advanced manufacturing. It is the manufacturing of these wafer chips in this process. But what the skill sets of individuals at the technician level, which is about 70% of the workforce that will work in the fabrication center, they're actually just advanced troubleshooters. They are looking at the enormity of this equipment that produces the chips themselves, which is mostly automated. But they have to be the instant response to any time any element goes down. If there is any shortage of the production line, they have to be the first responders. So they have to be trained in that skill set of troubleshooting, knowing how to use the tools and networks to respond to that. So we have to produce individuals who understand engineering components at least its base level, and then work in strong teams and units to respond to any shortage of production.
Well, it seems kind of ironic to me that we exported the expertise that's involved.
As the listeners should know, semiconductors were essentially invented in the United States, and particularly here in the state of California.
Mm-hmm. Yeah, and so here it is. We exported the expertise on this. I mean, I'd love to get a little historical perspective from Ashwin on why, but then also talk about, well, where the heck do you get the teachers from if there aren't any people around? So how did all of this come about?
Yeah, it's interesting to look back in history and wonder about these things. We talked briefly about the fact that the last time we built a wafer fab in the United States was probably about 30 years ago, and that wasn't in logic design. It was in memory design. And I think it was a facility that came up somewhere in Idaho that we made that investment in. And I think they're trying to expand that on the back of the CHIPS Act as well. There was a point in history where Japan was regarded as a potential technological threat. And multiple initiatives were undertaken by the United States, both from a government perspective and from a conglomeration of semiconductor wafer manufacturing companies at the time, to confront that particular threat that came from, that perceived threat that came from Japan. Japan had already made a name for themselves in miniaturizing technologies, and therefore seemed to have the native skill set to take anything, even wafer fabs, and perhaps do it better. So on the back of that, organizations were created that were spanning across players and looking at how to advance the state of technology and advance the state of knowledge, taking to make them manufacturable, those advanced technologies. Then something happened roughly around the beginning of, really in the middle of the 80s. Morris Chang was working here in the United States, a Taiwanese gentleman, and he looked at the state of the wafer fabs, and he decided that Taiwan might make for a good place to create a wafer fab, because Taiwan at the time was looking to make investments in becoming a part of the supply chain. He went back from the United States to Taiwan and created what today is TSMC. TSMC started as a contract manufacturer of silicon And that's all it was at the inception point. However, as is seen very often with such companies, they tend to climb up the value chain slowly but very surely. And today they're at a point where they define the manufacturing state of the art in terms of what is required from an equipment perspective to go to the next level of more detailed design. And that becomes an input parameter for the manufacture of equipment from different parts of the world. So what we have seen on the United States side is that, as recently as 35 years ago, we made more than 50% of chips here in the United States. Of course, chip demand was far lower at the time, but we practically made half of it. Today, that number is hovering around 10%. And after all the investments that we're talking about, the CHIPS Act with the $100 billion and the accompanying investments of $220 billion so far that's been announced, you put all of that together and you expect all of this to come online. And when everything that is now being promised is online, that number of 10% will have risen to maybe about 29, 30% at most.
Interesting. And, it's important that our viewers really understand the fundamental shift that we actually self-inflicted ourselves with, which was we made the decision to divorce the design of chips from the manufacture of chips. And we thought that was a really great thing, right? We thought, hey, who needs these dirty fabs? It's just manufacturing. It's the 3Ds, right? There's this commodity that we really don't have to worry about. What we actually found out was that there's actually a great deal of knowledge to be gained by having it together, right? That engineers that are designing things can tweak things when they are able to actually see it physically in front of them. And by removing the manufacturing process, we actually became less competitive, not more competitive. And so it's a kind of a long-winded back thing to you, John, of how will we be able to, and how will we be able to kind of re-glue those things together?
Yeah, I appreciate that. And Marshall, you asked the right kinds of questions. And I think we all saw some of those direct impacts coming out of COVID with supply chain relationships and how critical chips were to just about everything that we do and consume. And so I think the realization that even for areas like Central Ohio that aren't connected necessarily to this type of work and placement, we felt the direct impact of that shortage and understood why there was this desire to bring and reshore, retool, retrain. But we had to kind of gear ourselves up to be ready for that. It was once it was announced that Intel was looking to locate here in the Central Ohio area, it literally was an announcement, and the next day getting to work into business to look at this design, understand what it was that they do, how they do it, what it meant to us in terms of our foundation knowledge of the engineering process, how to adapt our student profile and our curriculum to what they were looking for. It's been interesting because this core work with electrical, mechanical engineering, that is somewhat transferable across the lines. And that's what they really basically told us is that's the core of what we need to have as skill sets. But there is some specificity to the work of the semiconductor network that we need you to help students become more versed in. They need to be understanding of clean room technology, of vacuum systems, because you all know that you have to have the utmost clean environment to work in, because even the smallest particles of dust on chips can be disastrous. So making sure that our students understood what that meant, how to work in that environment, what semiconductor processes really were. Interestingly, you will appreciate this, our first cohort of students are going through this system currently. My youngest son is actually a student of ours in the semiconductor network, and they are presenting their first Semiconductor 101 class presentations of their end result of knowledge and work. That's actually happening next week. So we've been asked to 4 times our production of engineers in the component, our institution specifically. The 2-year college network in the state of Ohio has been asked to create a 10 times network over the next 10 years.
And how many people is that in aggregate?
Yeah, if you really look at how many we're producing now, of the 23 two-year college network, we were talking somewhere within the 3,000 range. So obviously we can all do math. We need that to be 30,000 within the next 10 years. I can tell you right now, the good news is there's a lot of interest in this. There's got to be a lot of education that goes with, because people are interested in what this is, but how do I achieve it? What kind of credentialing do I need to achieve? What's the pay rate of return on that process? It's an education system almost from ground zero. And it's happening. It is just, it needs to happen so very quickly that we're putting a lot of resource generation into it, but seeing a lot of results as well.
And what is the pay rate, by the way? Just out of curiosity, somebody coming out of your program, how much were they going to make at a Intel?
Yeah, and this is an interesting one because this also is something we had to learn with Intel in terms of how they pay, where they pay. Someone making an engineering technician salary in Phoenix, Arizona, Portland, Oregon, that's going to be a different amount. And again, this is not surprising in terms of a pay scale. In the Central Ohio market, they're going to walk out with either a 1-year certificate in this industry or a 2-year associates as that entry portal at about $62,000. And in our network, that translates fairly well.
Yeah, it's a great starting point if you think of a career. I mean, it's a solid building block on which you can build a really good career, particularly when you're talking about the Midwest. My family comes from the Ohio Valley, so I can totally appreciate $62,000.
Well, and you come out of the industry.
Yeah.
Somebody that's coming in as an entry-level engineer at $62,000, what does their future earning potential look like?
Well, here is the interesting thing to think about, right? When you go back to the Great Depression, one of the factors that contributed to the expansion of the economy was the economic construct called mobility, where people were willing to go where the jobs were, as opposed to waiting for the jobs to show up at their doorstep. Now, imagine the semiconductor industry going through the build cycle that it now is, and just put yourself out at 2034, 10 years from today, when all of these wafer fabs in all different parts of the countries are up and running, and your job, your skill set, is still as valuable as it was the day you got certified. And you now have 10 years of experience under your belt. If you're willing to move to where the jobs are, you could be commanding a salary that's 2 to 3 times what it was when you first started. So you could be looking at $200,000 depending on where you're willing to move to, which I think is a phenomenal change.
Yeah.
Well, I was just wondering, John, in your case, I know Columbus has very strong positive net immigration, very different than much of the Midwest. Are you seeing students coming from other regions and other states to enroll in what you're doing?
Yeah, Joel, appreciate that. And one of the things that's interesting about our market is, and you hit this on the head, Central Ohio, particularly the Columbus metropolitan area, is in a significant growth arc. We are in conversation with Austin, Charlotte, those types of large scale growth. Most people don't realize that Columbus is the 14th largest city in the country. So when we're talking about bringing people into the workforce, we were already seeing that as a growth arc. Intel has really highlighted the semiconductor network an even greater viability. And we do see many, many individuals coming in specifically looking for that. One of the other areas of great growth right now is what we would call the first generation American populations. Individuals, particularly from refugee, asylee capacities that have found Central Ohio as a secondary home. We're doing a lot of training and development with that population arc right now. And once we overcome some of the English language skills, because that is a critical foundation, the ESL components, they make a wonderful workforce addition stream to what we're trying to generate from adult learners that are coming into the areas and homegrown for our K through 12 programs as well.
There is a certain, I don't know how to couch this, perhaps perversion is too strong of a word, but the CHIPS Act was written in such a way that it highly encouraged employing people who are local to where the investments were going in from a CHIPS perspective. So that said that if you invested in Ohio, they wanted that the labor force be from Ohio and not be imported from elsewhere. So there was no precognition of where talent was. On the contrary, it was almost like, let the chips fall where they may, and then we'll figure out the supply chain that needs to go hand in hand with it from a skills perspective. So much so that, to John's point, Central Ohio has never had a wafer fabrication facility. It's never been a foundry location. But they do have a rich history of being invested deeply in chemical technologies and in manufacturing. So that's a great combination to start with.
Well, and people need to understand that chip making is highly chemistry dependent.
Oh my God, is it ever? I mean, it's perhaps the most toxic manufacturing process in the world for anything. It's all chemicals. It's all chemicals.
Well, and what perfect place to understand toxic chemicals than Ohio?
Yeah.
Sorry, Ohio. I didn't mean that.
Actually, let me jump in on that because I appreciate your thoughts. There was some concern, and there continues to be, because we are still a heavily agricultural area as well. And Licking County, where this is located, is predominantly still a rural network. So this chemical manufacturing process, the sustainability, the impact that may have environmentally, that was a great concern from some of the general populace, and something we've had to work in tandem with Intel to make sure that we understand how to respond to that. And they have done a lot of public forum in relationship to that to allay some of those concern areas.
Well, and I think that, by the way, was one of the original arguments in favor of exporting fabs to begin with, was the notion that environmentally there'll be less stress on the U.S. Ecology if we export the toxic, manufacturing process.
And I think it comes down to the state level there, right? I mean, if you think of another industry like the oil and natural gas industry, for instance, Texas, Louisiana, Oklahoma, I mean, they are heavily invested in the technology, despite the fact that environmentally there's a lot that can be said and is happening. But it's a choice that they've made. You contrast that with California. I mean, I can't imagine anyone wanting to build mega fabs in California, given the kind of rules and regulations that we have with environmental factors in mind. So I think it's a choice that states are making, saying we're willing to because it will fill in the blank, whatever the blank is in case of each of the states.
Well, the follow on the feudal idea, this is one of the things that I find such a problem here in California, which is that we have a very large working class population, a very large immigrant population. But these would be, as you're finding in Columbus, those new Americans may be a great workforce. But if there aren't any opportunities for them, what we're going to have in California is a world where, yes, the chip designer makes a lot of money, and the people who invest in those companies make a lot of money, but there aren't a lot of jobs for regular people. And I think that's part of the appeal of the CHIPS Act and what you're doing. I guess the big question is, are the federal requirements so pervasive and perverted that it makes it harder to do it? I mean, you seem to feel like in Arizona that might be a problem.
It could be. The builders in Arizona, they have an association. First of all, Arizona had at least taken a few steps in terms of manufacturing facilities being built from a fab perspective. Intel has a fab there, has had one for many years. A little bit of local knowledge, perhaps, in that particular regard. But again, it's years and years. It's decades since they built a net new wafer fab there. And they were up in arms recently in the face of the CHIPS Act, saying, look, insisting upon this being local doesn't make sense. There simply aren't people enough to build this fab. It's just impossible for us to build this thing because we don't have the number of people who are qualified to build this fab. I mean, John referred to vacuum facilities and, extreme clean rooms and things like that. Talking about it conceptually is one thing. Building something like that is really, really hard. It takes specialized skills and knowledge to do that. Where is that knowledge? Well, it is where it chose to be. Because 30 years ago was the last time I expressed that knowledge. Now I might have chosen to go settle in Alaska. You can't say, well, you can't have an Alaskan working on an Arizonan facility, but he's the only guy who knows what to do about it. She's the only one who knows how to place this equipment in the right place. What do you do?
So I guess the question is, under the CHIPS Act, is it okay if somebody moves to Arizona or Ohio, or is it like did they check where you were born to see? No, you can't. You're a New Yorker. You're not allowed to work on this.
Yeah, and I would think particularly for what you're doing now. I mean, I assume that there are people from Taiwan who have unique knowledge that you have to bring in.
And Joel, I will tell you, it's been interesting because normally we're a regional-based community college system. Two-year colleges are generally serving a very restricted population. That is not the case any longer, particularly with this type of industry sector. We are sharing with people in Kentucky, West Virginia, Michigan, that these opportunities are here. And if you want to be a part of that, we are welcoming you into our communities and we will help educate you in this design.
Yeah, this will be a very interesting thing to monitor from a demographic perspective in terms of the shift. You know, your point about the Great Depression and people moving for work. That's where the expression "right if you get work" comes in. I wonder whether or not this will be a new version of that. You know, of people who are just relocating for what is obviously going to be a pretty sizable opportunity. If you're talking tens of thousands of people in Central Ohio and a similar number in Arizona, and we have
Texas.
other fabs that are legacy fabs that may, like the Mid-Hudson Valley, and where I grew up, near the Fishkill plant for IBM. It'll be interesting to see whether these places get revitalized or not as a result.
I think you're right. I think there's an opportunity here for multiple reasons for a longitudinal study, right? These fabs typically take 3 to 5 years even to get stood up and become operational. And once you stand up a fab, its lifespan is anywhere from 8 to 15 years, depending on how much more investment's going. If you invest only once, in 8 years' time, it becomes sort of trailing edge technology, just naturally. But if you continue to invest, it can last for 15, 20 years. Some of them last even longer. What they do is, if they have multiple wafer fabs, one gets mothballed, but it becomes refurbished completely to be at the next leading edge, and the next one, and so on and so forth. So Ohio, I think the facility there is going to have 10 wafer fabs if it's fully constructed. If that be the case, they can play this catch-up game forever.
And they continue with sunsetting and sunrising.
Sunrise, sunset. You know, you can play that game forever there. That could create an ecosystem where it is such an attractor that people keep coming in there saying, you know, I need a piece of that action because it's a well-paying job and I'm a highly qualified person. This is a good match.
You know, this notion of creating a regional ecosystem is something I'd love to get both of your thoughts on. If you look at the auto industry, Toyota being the exemplar of this, they created a kairitsu, right? They created a mutually beneficial, self-feeding, geographically specific supply chain.
And around Nagoya.
Yeah.
Right, around Nagoya, exactly right. Does semiconductors work the same way? Do you have regional suppliers that kind of feed off of the main fab, or is it a different kind of a supply chain?
And also in terms of being used downstream. I mean, obviously the reason the PC industry started in California is you had the chips to build the PCs.
Sure. Well, I'll take a stab at it. I'd love to hear John's view as well. The equipment supply chain is largely in 4 countries. And the invested base in making the equipment is so high that it's unlikely that those 4 countries will choose to co-locate and create a local center anywhere in the world. So in large measure, the equipment is made in California, not in the United States, made in California, made in Germany, made in the Netherlands, and made in Japan. And these are different elements, and they're almost mutually exclusive, and yet they're all an integral part of the manufacturing line that needs to come together.
Yeah, and people need to understand this is one of the world's most complex supply chain or manufacturing processes, right? There's 200 steps to be able to make chips.
Yeah, that's right. I don't think that there is any other manufacturing that's anywhere close to this level of precision, sophistication, or complexity. I mean, it's a hellish mix if you think about it. I mean, this is a nightmare of a production line because one mistake anywhere in 200 steps and you get a wafer lot that's worthless.
Yeah, so actually the short answer is no. It's not likely that this will create a Kairos-like regional center that at least consists of the supply chain.
For manufacturing, so if you set aside the manufacturing line itself, there is not likely to be a Kairos. Now, if you think about the line is up and running and it needs stock feed to come in from the input side in order to create wafers on the output side, which are actual chips. Now, that stock feed perhaps has the potential to be created into a Kairos locally. And there, I think, when I think of Ohio, there is a natural advantage because they have been in chemicals for such a long time. They could repurpose themselves and say, based on this, I could turn left and suddenly become a critical component supplier here.
But the stock portion of it is what you're saying is a relatively small part of the overall process.
Yes, but it has longer legs in that whereas the equipment is one and done, the stock is forever if you create a forever kind of a system there.
John, are you seeing other suppliers besides the Intels of the world coming to you and saying, hey, we need to train people on that stuff too?
Yeah, I'm Marshall. That's a great question. And Ashwin is absolutely right about the large scale production, the equipment pieces that constitute the fabrication center. They're coming from outside in, and we knew that. But Intel was very open with us about smaller supplier networks that they will need to have either groups locate into Ohio or utilize pre-existing Ohio-based companies to provide some of that supplier engagement. Not necessarily the large-scale fabrication mechanisms, but all those supply. And here's just a silly example in Pataskala, Ohio, which is about 10 miles from the fabrication center. We now have clean room suit producers and clean room suit cleaners, so which we've never had before and never thought about. But because of those bunny suits needing to be so viable in this clean room technology. So it's those kind of smaller based supplier connections that we're seeing more and more of. But this system, as most of you all know, is a fairly secretive process. They keep a lot of information close to their vest, and we are seeing supplier connectors come into our systems fairly rapidly, but we don't know them ahead of time. Oftentimes it's when they arrive, then we learn a little bit more about them and who they are, what they do, and what can we do to help combine those networks.
Well, so obviously before we leave this topic, we're going to have to deal with the politics. Obviously, this is part of the growing geopolitical struggle between the United States and probably some of the other key players, UK, Japan, South Korea, many of them with important technologies.
And China.
But this is as an opposition to China. Are you finding anything in the CHIPS Act that is politically difficult for you? Ohio is a red state basically, but there are some people on the right, for instance, who are against anything like the CHIPS Act, and of course, if you read the Wall Street Journal, they take a shot at it as much as they can. How's the politics played out in Ohio?
Yeah, that's a great question. And I will tell you that obviously we are at least versed in some of what is happening at an international level, but within the state construct, it's probably even more definitive. I would say that, and particularly in an election year, this becomes a fairly volatile issue, given the fact that as a state, we appreciate the economic impact of this, what it means in terms of job workforce creation, and even candidly, notoriety of the state. Ohio doesn't always get the notoriety of a California, and especially in this kind of space. So there is that margin, and we have a number of what I would call my diehard Republican friends and colleagues within our state legislature who do see that first and foremost before party loyalty. But I can also tell you that it's a mixed bag. And there are some on that side who really see this as a leftist type of organization and a process point that they don't necessarily support more from the philosophical than the pragmatic. So we're seeing some of that struggle. But at least from our governor's perspective, both the governor and lieutenant governor are profoundly entrenched on the platform of economic development and workforce enhancement. So I would say to you, we're in this for the long haul, regardless of that. And Joel, you'll appreciate this. We're a red state until it becomes issue-based, and then we're very, very purple. And so,
well, I've got a.
And I understand both of your senators, one quite far to the left and one quite far to the right, are both behind what you're doing.
they are.
Right. Which would make sense because it's a real bread and butter issue for them. But I'd like to elevate this to where you were going with the global geopolitical issue. So if you step back and you think about the impetus for the CHIPS Act, the notion was to try to restore some power to the U.S., who arguably goofed up by having exported this technology out to begin with. Is it going to do that? This is the big final question. Is the U.S. really going to be able to create preeminence, or at least the alliance that they put together create preeminence that will make it strategically advantaged? What do you guys think about that?
Yeah, this is really the key takeaway question for this whole session.
So I'm going to hedge here because I think that is the current state of the world. So let's talk about it in different ways. It is a complex picture. It's a complex question, and therefore it's a complex picture. We didn't recognize as early as our geopolitical opponents did that the promise of artificial intelligence particularly comes with a lot of perils that are not yet understood, leave alone completely articulated and accounted for. On that basis, we went at it with an open market focus, whereas our geopolitical opponents went at it from a state focus. Very different perspectives. By the time we woke up to the fact that this could spell disastrous results for nation states, including our own, I think the horse was out of the barn, so to speak. But we took rearguard action very fast, saying we will have export controls that will prevent leading-edge technologies from reaching the hands of our opponents on the global geopolitical stage. And if you go back in history, from a Taiwan perspective, being very specific to Taiwan, we've had loose support considerations for Taiwan, saying that they will not be attacked. But there isn't a treaty. They're not a treaty country with us, so to speak. But we've had joint exercises with them forever, almost 50, 60 years, in support of their being a standalone. The fact that TSMC is there and is now manufacturing the most leading-edge technology chips in semiconductors is an obvious geopolitical threat, given the state of world affairs. So now the question becomes, can you have just regulatory conformity preventing whatever technologies from reaching the hands of untoward opponents? That's an if on a good day, because the buyer-seller of any given transaction may only be visible up to a certain point. There are aftermarkets and aftermarkets and so on and so forth. It's recursive to the nth.
Yeah, look at the effectiveness of sanctions on Russia.
Exactly.
There's ways around these things.
There are ways around it, and there are people who are willing to break from whatever it is that you're defining as the rules-based order. There may have been a point in time, I think there was a unipolar moment that lasted for about 10 years, when the U.S. said that these are the rules and the rest of the world said yes. But those days are behind us. They're not ahead of us, which says that there are plenty of countries that can break rank and say, well, we choose not to play by your rules because they were your rules, not our rules. So that says that these market conditions that we're trying to now enact legislation with will rely upon cooperation from a large number of countries, if not all countries. When the threat was much more visible, like it was with nuclear fusion, I think it was easier. But trying to figure out how to make leading edge technology like artificial intelligence become real is very hard, because most people barely understand what people are talking about when they say artificial intelligence. It sort of reminds me of Daniel Kahneman, who recently passed away. As you know, he was asked the question, what do you think of artificial intelligence? He said, I'm too busy dealing with natural stupidity.
Yeah, I love that line. But you're right. I mean, it's kind of easier to get people to see the threat of being blown to bits by nuclear warheads than it is for them to see the threat of humanity being extincted from artificial intelligence. It's just not that clear.
Yeah.
So I can see that the how do you develop a coalition of the willing in that kind of a world?
So maybe the last thing would be, John, we're going to ask you, what are our chances of achieving this strategic goal, and what are the biggest things that have to be overcome from your point of view?
Yeah, I appreciate that. And I will kind of echo and play off a little bit of what you just heard from Ashwin as well. I'd say we, and with our good Midwestern sensibilities and our aptitude to think of the common good, have listened to this need to shift from the service of commodities to the service of technology. That it hits home, it resonates. As we talked about earlier, we felt the chip manufacturing decline over COVID with the supply chain, when you couldn't buy a new car or a truck because it wouldn't start because of the lack of chips accessibility. And it's funny because I appreciate what you were just saying too about nuclear warheads, we understand, but I think we've all seen Terminator, that movie, enough to know what really could happen if AI moves into a really negative state. So from our vantage point, we kind of see the role that we're playing as our localized addition to a globalized need. So for us, it is a rallying point in some ways. It's more of an altruistic purpose that, hey, you want to be a part of this next generation of technology, design, production, reshoring, retooling, resecuring our borders. This is something that you can do through the state of Ohio to impact that process. So again, when we talk about the interest generation, having people look at this as a viable opportunity, it is there. That we're fielding literally hundreds of calls a week about what could this mean to me? How can I engage in this? What would I be responsible for? If we can couple the construction and the design of these fabrication centers to the nth degree that we've talked about, 2 has been a heavy lift, 10 would be an enormous one. But if we get the first 2 right, and we do what we're duty bound to do for both construction and the workforce flow, I can see this being something that the state of Ohio is committed to for 50 plus years.
Well, from your mouth to God's ears, as we would say.
Well, this is a very exciting. This has been a very exciting conversation, both at the human level in terms of human opportunity, the state level, and what's going on in Ohio and in other parts of the country, and from a global perspective and a technology perspective. So, gentlemen, thank you very much for joining us.
Absolute pleasure. Thank you all for having us from a distance.
Thank you.
And thank you for watching another episode of the Feudal Future Podcast.
The Feudal Future.